Hello and welcome. In this video, we'll walk you through everything you need to know about ISO 9241 Guideline for Ergonomics of Human-System Interaction, in simple, clear terms. In a human-centered design process, each team has a clearly defined responsibility that must be followed. The UX design team must design user-centered interfaces based on user needs, tasks, and usability principles. They have to ensure that the experience is intuitive, efficient, and aligned with real user behavior. The software team must implement the interface logic while ensuring usability, performance, and accessibility requirements are met. They have to translate design into a functional and reliable system. The team lead must oversee the entire human-centered design process, coordinate between teams, and ensure that all activities comply with ISO standards and project requirements. Following ISO standards is essential to ensure better product quality and user experience. It improves overall user experience by making systems more intuitive and easy to use. It reduces errors and user frustration by ensuring designs are tested and validated. It also increases productivity as users can complete tasks faster and more efficiently. ISO standards help ensure legal and accessibility compliance, making products usable for a wider range of users. Most importantly, they provide a structured, human-centered design framework, ensuring that user needs are always at the core of the development process. ISO 9241 defines a set of standards that guide human-centered design and usability in systems. ISO 9241-11 defines usability through measurable factors like effectiveness, efficiency, and satisfaction. ISO 9241-110 covers dialogue principles, guiding how users interact with systems in a clear and intuitive way. Next, we'll walk through ISO 9241-11. It defines usability as how effectively, efficiently, and satisfactorily users can interact with a system in a real context of use. ISO 9241-11. Usability definition and metrics establishes how usability is defined and measured in real systems. It includes effectiveness, validation data, efficiency, satisfaction, context of use specification, user persona, types of user persona, measurement and documentation requirements, usability issues CTA, and types of CTA. These collectively ensure usability is not subjective, but quantifiable and testable. Effectiveness must ensure that users can successfully complete core tasks without failure. The UX team must define measurable success criteria for all core tasks, such as placing orders, submitting forms, or generating reports. Success criteria means defining how we know a task is successfully completed. For example, if a user places an order and reaches the confirmation screen without errors, the task is successfully completed. Task completion rate must be maintained between 85 to 90% during validation testing, and critical error rates must remain below 3%. Critical errors where the user gets stuck or cannot proceed further in the task. How to measure. All effectiveness metrics must be validated with representative users, with 5 to 8 users for formative testing and 15 to 20 users for validation. The software team must implement strong validation logic, clear error states, and reliable recovery mechanisms. Validation logic is the set of rules in an app that checks whether the data entered by a user is correct, complete, and usable before it is accepted or processed. The system must ensure that users can complete tasks without breakdowns or critical failures. For example, in a food delivery app, when a user enters a phone number, the system checks if it is exactly 10 digits. If the user enters 98765, the app shows an error and does not proceed. Validation data includes different input types such as correct, incorrect, boundary, null, and special character data to ensure the system handles all scenarios effectively. It helps verify data accuracy, prevent errors, and ensure system reliability and security. Correct data testing ensures the system accepts valid and complete inputs. The input meets all validation rules and should be processed without errors. This confirms the system works as expected under normal conditions. For example, the user enters a full name like Rohan Mehta. This meets the required format and validation rules, so the system accepts the input successfully. Incorrect data testing checks how the system handles invalid inputs. The system must reject such inputs and provide clear error messages. This prevents incorrect or low-quality data from entering the system. For example, if the user enters only a single letter like A or numbers, this does not meet the required name format. So the system shows an error and rejects the input. Boundary data testing verifies system behavior at minimum and maximum limits. It ensures the system handles edge cases correctly without failure. This is critical for maintaining system stability. For example, if the minimum length is 3 characters, an input like RO is rejected, while ROS is accepted. This confirms the system handles boundary conditions correctly. Null data testing checks how the system behaves when no input is provided. The system should not proceed and must enforce mandatory field validation. This ensures data completeness. For example, if the user leaves the name field empty, the system should not allow submission. Instead, it prompts the user to enter the required information. Special character testing ensures the system handles symbols safely. It helps prevent security risks and incorrect data formats. The system should validate and sanitize such inputs. For example, if the user enters a name with special characters like Roshan at Meta, this does not follow the allowed format. So the system rejects or sanitizes the input. Efficiency must ensure that users can complete tasks quickly with minimal effort and system delay. The UX team must measure time on task, number of steps, and cognitive load for all key interactions. Time on task must not exceed 120% of expert benchmark time. Expert benchmark time is calculated by averaging the time taken by multiple experts to complete the same task. Interface response time must remain within 2 to 3 seconds, and feedback within 100 milliseconds must be perceived as instant. The software team must optimize back-end performance to minimize delays. API latency must remain under 500 milliseconds. The system must be tested under load conditions, and load testing must simulate up to 2 times the expected peak traffic to ensure consistent performance under stress. Satisfaction must ensure that users feel comfortable, confident, and positive while interacting with the system. The UX team must measure user satisfaction using standardized tools such as the system usability scale. The system must achieve a score of at least 70 for acceptable usability, with higher benchmarks indicating better experience. Post-task ratings must average at least 4 out of 5 for critical workflows. Qualitative feedback, including user comments and emotional responses, must be collected to support and explain quantitative results. The software team must ensure visual stability across the interface and must prevent layout shifts during interaction. The system must maintain a crash rate below 1% of sessions to ensure a smooth and reliable user experience. Context of use must ensure that usability is evaluated based on real users, real tasks, and real environments. The UX team must define and evaluate usability within a clear context, including user groups, tasks, equipment, and environment. They must document user characteristics such as skill level, frequency of use, and accessibility needs. Testing must reflect real-world conditions, including device types, lighting conditions, and network constraints. The software team must account for variations in device performance and ensure compatibility across different browsers and platforms. Accessibility must be strictly maintained, and the system must comply with WSAG 2.1 AA standards, including a minimum contrast ratio of 4.5:1 and full keyboard operability. Contrast ratio defines the difference between text and background for readability. A ratio of 4.5, 1 or higher is good and ensures clear visibility, while lower contrast is poor and makes content hard to read. A user persona is a fictional representation of a target user, created based on real research, data, and user behavior. It helps teams understand user goals, needs, and pain points so that design decisions are more focused and user-centered. A typical persona includes key information such as the user's name and profile, demographics, behaviors, preferences, and challenges. It also highlights their goals and motivations, giving a complete picture of how they interact with the system. By using personas, teams can design with more clarity, reduce assumptions, and create better user experiences that truly meet user needs. To design an effective system, it is important to first understand for whom we are designing. To understand our user better, we practice user persona. We'll take an example of food delivery to understand their user's need. First, we will cover customer needs. This customer persona focuses on understanding how users interact with the food ordering experience within the app. It helps us identify key behaviors, preferences, and decision-making patterns that influence how users place orders. We analyze not just what users do, but why they do it, looking at their expectations, pain points, and trust factors throughout the journey. By studying these aspects, we can design an experience that is intuitive, efficient, and reliable, ultimately reducing friction and improving overall user satisfaction. For instance, when a user opens the app late at night expecting a quick order, any complexity or overload can lead to drop-offs. Understanding such scenarios allows us to design smarter solutions like quick reorders, personalized recommendations, and streamlined checkout flows. Moving from understanding the customer experience, we now shift focus to the delivery side of the journey. This delivery agent persona focuses on understanding how delivery partners operate in real-world, on-ground conditions. It explores their movement patterns, navigation challenges, and ability to manage efficiency under varying workloads. We also study how they interact with the app while on the move, especially their dependence on real-time updates, such as traffic conditions, order changes, and customer communication. Common challenges like incorrect addresses or unreachable customers are analyzed to identify gaps in the system. These insights help us design a solution that is fast, reliable, and easy to use in high-pressure situations, ensuring minimal interaction, clear guidance, and improved delivery efficiency. For example, during peak traffic hours, a lack of real-time navigation or clear address details can cause delays. By understanding this, we can introduce features like live traffic updates, one-tap calling, and clear delivery instructions to improve speed and overall delivery experience. After understanding both the customer and delivery perspectives, we now move to the vendor side of the ecosystem. This restaurant vendor persona focuses on how vendors manage incoming orders as part of their daily operations. It looks at order volumes, kitchen workflows, and preparation timelines to understand operational efficiency. We also study how vendors handle orders, whether they accept, delay, or reject them, and identify communication gaps with delivery agents. Additionally, system performance during peak hours is evaluated to uncover bottlenecks. These insights help us design a system that enables quick decision-making, clear communication, and efficient order handling, reducing delays and improving overall service quality. For example, during peak lunch hours, multiple orders arriving simultaneously can create confusion if priorities and preparation times are unclear. By addressing this, we can introduce features like order queue management, prep time indicators, and quick action options to streamline operations and ensure timely delivery. Measurement and documentation must ensure that usability is tracked, validated, and clearly recorded for decision-making. The UX team must predefine usability metrics before testing begins, and no post-hoc metric selection must be allowed. A minimum of 5 users must be included in formative testing to identify up to 85% of usability issues. A global usability issue is a problem in an app or website that affects many users across multiple tasks or screens, not just one specific feature. Validation studies must include 15 to 20 users to ensure statistical reliability. The software team must continuously log system errors, response times, and crash analytics. All usability results must be properly documented in a usability test report, and full traceability to defined requirements must be maintained. A call to action, or CTA, is a UI element that prompts users to take a specific action, such as buy now or submit. It helps guide users through the interface and move them toward completing a task. CTAs are useful because they reduce confusion, provide clear direction, and improve task completion rates. In UX design, they play a key role in driving user engagement and conversions. That's why CTAs are designed to be clear, visible, and action-oriented, ensuring users always know what to do next. There are different types of CTAs, such as primary and secondary, each designed to guide users based on the importance of actions. The primary CTA is the most important action on the screen. It is designed to stand out visually and guide the user toward the main goal. UX design ensures it is clear, prominent, and easy to access. For example, in a food delivery app, place order is the primary CTA, as it completes the user's goal. The secondary CTA provides additional options without competing with the main action. It supports user flexibility while keeping the primary goal clear. UX design ensures it is visible but not dominant. For example, alongside place order, a view details or add to wish list button acts as a secondary CTA. Next, we'll walk through ISO 9241-110. Dialogue Principles establishes guidelines for designing interactive systems that are intuitive and user-centered. ISO 9241-110. Dialogue Principles defines how interaction between user and system should behave. It covers suitability for the task, self-descriptiveness, conformity with user expectations, suitability for learning, controllability, error tolerance, and suitability for individualization. These principles ensure interfaces are intuitive, predictable, and adaptable. Suitability for the task must ensure that users can complete their goals efficiently without unnecessary effort. The UX team must design the system to support task completion without unnecessary steps. Workflow steps must be minimized, and redundant data entry must be avoided to reduce user effort. Task completion rate must target 85 to 90% during usability validation. The software team must automate repetitive actions such as autofill and smart defaults to improve efficiency. System response time must remain within 2 to 3 seconds. Complex workflows must be structured into manageable and logically grouped steps to ensure smooth task execution. Self-descriptiveness must ensure that users always understand what is happening and what action is required next. The UX team must design each dialogue step to clearly indicate system status and the next user action. Clear labels, tooltips, and feedback messages must be used throughout the interface. System feedback must appear within 1 second of user actions to maintain clarity and responsiveness. The software team must ensure real-time validation and provide clear status indicators such as loading, success, and error states. Error messages must clearly state the cause and provide a solution, and generic messages must not be used. Conformity with user expectations must ensure that the system behaves in a familiar and predictable way for users. The UX team must design interfaces that follow established conventions and mental models. For example, placing the Add to Cart button in a standard location helps users quickly understand the action. The design must align with platform standards, such as common navigation patterns, and consistency must be maintained across all screens to reduce confusion. The software team must ensure uniform interaction behavior across all modules. For example, if a button click opens a new screen in one section, it must behave the same way everywhere. Usability testing must confirm that users find the system familiar, and error rates for routine tasks must remain below 5%. Suitability for learning must ensure that new users can easily understand the system, while experienced users can work faster over time. The UX team must design the system to support both beginners and experts. For example, a new user should be able to complete a task like placing an order without external help, at least 75% of the time, using clear onboarding and guidance. The software team must enable efficiency for expert users by providing shortcut keys, keyboard commands, or automation. For example, an experienced user may use shortcuts to complete the same task faster. Over time, the system must show a learning curve where users improve speed and efficiency with repeated use. Controllability must ensure that users have full control over their actions and can easily correct mistakes. The UX team must design the system so users can control pace, sequence, and undo actions. Options like cancel, back, undo, and confirmation must be provided for critical tasks. For example, if a user deletes an item, they must get an option to undo the action instead of losing it permanently. The software team must implement reversible operations and maintain safe system states. Autosave must be enabled to prevent data loss, such as saving form data automatically. Critical errors must remain below 3%. Critical error is a mistake that prevents the user from completing a task, and recovery must be possible so users can continue their task without starting over. To check critical errors, track logs, error events, failed transactions. For example, when payment API fails or app crashes during checkout, user cannot complete order, it is a critical error. Error tolerance must ensure that users can avoid mistakes and recover easily if errors occur. The UX team must design the system to prevent errors and allow easy correction. Constraints such as drop-downs and masked inputs must be used to reduce invalid entries. For example, instead of typing a date manually, users can select it from a calendar to avoid mistakes. The software team must implement input validation on both client and server sides. For example, if a user enters an invalid email, the system must immediately show an error and guide correction. Error recovery must allow at least 90% of users to successfully complete the task after correction. And crash rates must remain below 1% to ensure system reliability. Crash rate is the technical failures causing the app to stop. App crashes when loading payment gateway due to a bug. Logged as a crash event. Suitability for individualization must ensure that the system adapts to different user needs, preferences, and skill levels. The UX team must design for customization, allowing users to adjust themes, layouts, or language settings. For example, a user should be able to switch between light and dark mode or choose their preferred language. Accessibility must also be ensured, meeting WCAG 2.1 AA standards so that users with different abilities can use the system effectively. The software team must support these personalization features through a scalable system architecture. For example, even when users apply custom settings, the system must continue to perform smoothly. Performance must remain stable and reliable, ensuring a consistent experience for all users. Accessibility is not the responsibility of a single team. It is a shared commitment between UX and software development. It must be embedded from the beginning, designed with clarity and inclusivity, and implemented with precision using proper standards and validation. The call to action is clear. Design with intent, build with responsibility, and ensure accessibility is the default across every stage. Thank you.